don't know. We can't get our microphone working.
Okay,
So.
that's fine. All right, so what are we doing? You got finals coming up next week, or?
Yep, next week.
Okay.
So let's see. We're finishing up like our last thing we actually need to learn new thing, and then it's going to be reviewed. But so we're working with like trig function or solving trig functions.
Okay.
So I just have a couple problems. Let's see. Okay, so the first one, this is like I think this is just a basic problem because like a lot of them are like this. This one, it has a domain of negative pi is less than or equal to x, and then x is less than or equal to pi.
Okay.
And then it wants you to find the possible values of 2x plus pi over 2.
Well, let me get this straight. They want you to find the values of x that would leave it in that domain?
Yeah, I think that's what
There's no equation? Just an expression?
Yes, it's just what's up there.
Okay. So what we really mean then is this has to be less than or equal to pi, and then solve a separate one that has to be greater than or equal to negative pi. Right? Okay, so if we take the first problem, multiply everything by 2, we get 4x plus pi less than or equal to pi, 4x x less than or equal to 0. Huh? Hold on a moment. Let's see. What did I do? Oh, I didn't put the 2 pi over there. Okay, so now I get x is less than or equal to pi over 4.
Wait, why is it 2 pi?
Well, because I multiplied everything by 2 to get rid of that denominator.
Oh, okay.
Okay, and then I move the pi over, and I got 4x is less than or equal to pi, so x must be less than or equal to pi over 4. That makes sense, because any x greater than that will make this whole thing greater than pi. Okay, now let's solve the bottom one. Bottom one is 4x plus pi is greater than or equal to minus 2 pi. So, go ahead. Uh-huh. Yep.
So for the first problem, when you multiply it, sorry.
That's okay. That's okay. No, I want you to stop and go back if ever you're not understanding what I'm doing. Okay, so in this one, we've got 4x is greater than or equal to minus 3 pi, which means pi is greater than or equal to minus 3/4. I mean, x is greater than or equal to minus 3/4 pi. So our final solution is x has to be less than or equal to pi over 4 and greater than or equal to minus 3 pi over 4. And let's see if that works, because so I'm saying pi has to be greater than minus 3/4 pi. So minus pi over 2 would be in this interval. And if x were minus pi over 2, then I'd have minus pi plus pi over 2. That's minus pi over 2. So that works also. So x has to be in that interval between pi over 4 and negative 3 pi over 4. Now, hold on a minute. There's something about this whole thing I don't understand.
In the book it has a different answer.
Well, I'm not surprised because clearly x is between minus pi and plus pi, and I come up with a different set of x values. So I'm not quite sure what they want here. I'm not sure what the problem is asking. When it says 2x plus pi over 2, what is that supposed to be equal to? What answer do they have in the book?
They say negative 3 pi over 2 is less than or equal to 2x plus pi over 2 is less than or equal to 5 pi over 2.
Oh, I get it now. Okay, now I understand. Let's go back and do the problem again. The domain of x was minus pi to pi. Okay, so let's start there. In other words, here's what I'm looking at. X is greater than or equal to minus pi and less than or equal to pi. So how do I create the domain for that? And that's what they're asking, is what is the domain of 2x plus pi over 2? Right? Okay, well, let's multiply this thing by 2 everywhere. And then let's add pi over 2 everywhere. And we end up getting their answer. In other words, all I'm doing is starting with x, and I'm creating 2x plus pi over 2. And what I get over here is minus 3 pi over 2. And what I get over here is 5 pi over 2. In other words, you start with x and its domain, and then you build up, you do whatever you have to do to x to make whatever's in the middle there be 2x plus pi over 2. If they'd have said 2x plus pi over 3, then I would have multiplied the inside by 2, and I would have added pi over 3 instead of pi over 2 to the inside. I'm sure that's what they do in your book also. That's how they arrive at this answer. Okay, what else you got?
So this one says solve exactly for 0 is less than or equal to x less than or equal to 3 pi. And then it goes on, and then it says cosine of x equals 1/2. So I guess that's the domain.
That's the equation. This is completely different. Well, what we're going to do on this problem is completely different than the other problem.
Okay.
We need to solve this equation, and we want to come up with answers that are in this interval.
Okay.
So let's solve that equation. How do I solve for x? By definition, what is x equal to? Forget the domain. Just look at cosine x equals 1/2. By definition, what does that mean? X equals what? the inverse cosine of 1/2.
Yeah.
In other words, you take trig functions of angles to get numbers. You take inverse trig functions of numbers to get angles. X is going to be an angle. So now the name of the game is, where is the cosine equal to 1/2 in that 1.5 unit circle domain? Well, where's the first place? What's the first quadrant angle that is correct?
60 degrees of pi over 3.
Okay, where else in the unit circle? Let's just go through the unit circle. Where else is cosine positive 1/2?
And then it would be 2 pi over 3?
No, we're in the fourth quadrant where cosine's going to be positive again. In other words, if we look at our unit circle, we got all students take calculus. Cosine's positive in first and fourth. So we need the equivalent first and fourth and first again, because we're going to 3 pi. So what's the fourth quadrant angle that is the equivalent of pi over 3?
7 pi? Or shoot, wait.
You're close. Start with 2 pi and take away pi over 3. In other words, that's what the formula is it's 2 pi minus theta gives you pi over 3. So theta would be 2 pi minus pi over 3.
Wait, it would be what?
Okay. Here, let's just review these. This one is pi minus theta. This one's theta minus pi. These are the formulas to get the reference angle. Okay? So if I know that that needs to equal pi over 3, in other words, 2 pi minus theta, how does that equal pi over 3? Well, move theta to the right, that to the left, and you get 5 pi over 3 equals theta. So 5 pi over 3 is our fourth quadrant angle. Now, that covers from 0 to 2 pi, once around the unit circle. Well, their domain said go from 0 to 3 pi. Well, that's 1.5 times around the unit circle. So what is the coterminal angle for pi over 3?
Wait, what do you mean? Like is it
Start with the first quadrant and just add 2 pi to it. Yeah, because it's in the fifth quadrant, so to speak. In other words, if that's 1, 2, 3, 4, and 5, and 6, those are our 6 quadrants that we have to look at. Because we're going from 0 to 3 pi.
So is it 7 pi over 3?
Yeah. And only that one. In other words, only the fifth quadrant one. Because cosine's not positive in the second or sixth quadrant.
Yeah.
So there's your 3 answers.
Okay.
What else?
Let's see. This is where it's the same domain, formula.
Okay.
Oh wait. So wait, where does that formula come into that problem? The 0. Oh, that just tells me
That
where.
told me how many times to go around the unit circle.
Okay.
Once around the unit circle is 0 to 2 pi. And that's the typical domain. On most trig equations, the domain is going to be 0 to 2 pi. So when they go 0 to 3 pi, we got to go around 2 pi and then another pi. That's quadrants 1 through 6.
Yeah.
All right.
So this one also goes to 3 pi then.
Okay.
And it's cosine of x plus pi over 2. Equals 1/2. So do you just...
Is it like that?
Yeah.
Okay.
Yeah.
That's different. In other words, if I didn't put those parentheses around there, it's completely different.
Okay.
Because it would then be the cosine of x plus this number equals that number. So I would subtract pi over 2 from both sides and go from there. But this is a different problem. This is a little harder. Let's see. Cosine of x plus pi over 2 equals 1/2. You think for a minute here. Do I want to use the sum and difference? I don't think so. Because then I'm going to have 2 cosines and 2 sines. And I'm going to have a variable with each one. I mean an x with both. First of all, let's think about this a little differently. Let's think about the unit circle, and that is the angle where the cosine is equal to 1/2, right? Pi over 3. Correct?
Mm-hmm.
Okay. Well, why isn't pi over 3 the answer? Because notice that when I add pi over 2, I go to the reference angle in the next quadrant. Right?
Yeah.
Okay. So obviously pi over 3 isn't an answer because pi over 3 plus pi over 2 puts me in the second quadrant. So that's not going to give me a positive 1/2. There's a better way to do this problem. I just realized. Okay. So what we have here is, if this is true, then x plus pi over 2 equals the inverse cosine of 1/2. Right? By definition?
Yeah.
So x is equal to the inverse cosine of 1/2 minus pi over 2. So now we have to figure out all the places in the first 6 quadrants where this is true. Well, what's the inverse cosine of 1/2?
Pi over 3.
Okay. So let's substitute. That's one of them. What's pi over 3 minus pi over 2?
Negative pi over 6.
Yes. That's one of our answers. Notice that negative pi over 6 is negative pi over 6. Hold on. If I add pi over 2 to that, I get cosine of pi over 3 equals 1/2. So that clearly is one of my solutions. Okay?
Wait. Okay.
Now, you can turn that into a positive angle if you like. That's 5 pi over, that's 11 pi over 6. In other words, so let's list our solutions. In fact, minus pi over 6 is not a solution. Sorry. Because it's not in our domain. Our domain is from 0 to 3 pi. So let's keep going. In other words, let's not start there. Where is the next place where this is true? Besides pi over 3. In other words,
pi over 3.
Where is x plus pi over 2 equal, hold on, let me think for a second. In other words, we've got multiple answers for inverse cosine of 1/2. Okay, yeah. Let's start. What are our multiple answers for that?
Pi over 3.
Okay.
And then 5 pi over 3.
Let's start there.
Okay.
Okay, so now I'm going to solve this equation using both of these answers. And in fact, yeah, no, that's a good way to start. Okay, so I need to add, I subtract pi over 2 from that. That gave me minus pi over 6. That's not inside my domain. So let's go to the next one and subtract pi over 2 from this one. What does that give me? Let's see, 10 pi over 6 minus 3 pi over 6 is 7 pi over 6. There's our first answer, 7 pi over 6. Does that satisfy it? It sure does. 7 pi over 6 plus 3 pi over 6 is 10 pi over 6, and 10 pi over 6, the cosine's equal to 1/2. Okay, you with me?
I think so, yeah.
Okay, this is not an answer. So let's keep going. Let's find the next spot, because we've got to go all the way. We can go all the way up to 3 pi. We have to just keep going and keep finding the next place as we go around the unit circle. Well, the next place is 7 pi over 3, right?
Yeah.
Okay, let's subtract pi over 2 from that. What do you get?
11 pi over 6.
Uh-huh. Let's keep going, because we still have not reached our 3 pi domain. So where's the next place? Okay, notice these are separated by 2 pi. Well, the next place is going to be 2 pi more than 5 pi over 3.
9 pi,
I think that's, let's see, if I add 6 pi over 3, I got 11 pi over 3. Okay, that's the next place where cosine, now subtract pi over 2 from that. What do you got?
19 pi over 6.
That's outside our domain. Right?
Yeah.
So these are our only 2 answers. Why does it seem like 15 pi over 3 should work? Let me just test this real quickly. 15 pi over 6 minus pi over 2. No. Hold on. Yeah, no, I don't think I've done anything wrong here. I think that is the right answer. Even though this is inside 0 to 2 pi. But notice that first answer we got of minus pi over 6, that's the same angle as 11 pi over 6. So really, our first two answers came from this one and that one. Make sure you understand what I did here. I started, so 7 pi over 6 and 11 pi over 6 are our answers. Make sure you see what I'm doing here. In other words, if this is true, then it means that this angle is equal to the inverse cosine of 1/2. Because I can always take the inverse cosine of both sides. And when I take the inverse cosine of the left, I get the angle, x plus pi over 2. When I take the inverse cosine of the right, I get inverse cosine of 1/2, which has multiple answers. It has that answer, it has that answer. It also has this answer and this answer. But by the time we subtract pi over 2 from each of those, which I have to do because in order to solve this for x, I got to subtract pi over 2 from both sides of the equation. That's how I got pi over 3 minus pi over 2. Was this pi over 3 is the inverse cosine of 1/2. Okay, and then I subtract the pi over 2 that comes from over here. So that first answer gave me minus pi over 6 outside our domain. We just keep going around the unit circle, finding other places where cosine is equal to positive 1/2. We're going to find every single place, going up as high as we have to, subtracting pi over 2 from it, and taking all of our answers that are inside of 3 pi, inside of our domain from 0 to 3 pi. And notice as we did that, the next place was 7 pi over 3, but that's how I got the 11 pi over 6 answer. But then the next place was here, and when I subtract pi over 2 from that, I get 19 pi over 6, which is outside of 3 pi. That's greater than 3 pi. So this one doesn't work, and this one doesn't work. The only two answers we have left are that one and that one. The IB program definitely has its unique take on things. It's different than most everybody else who teaches. Everybody else's trig programs are not like these questions. Everybody else's trig program, the domain goes from 0 to 2 pi, and you get equations like sine squared of x minus sine of x minus 2 equals 0. Stuff like that. Now maybe you have some of these also. I would expect you would.
Yeah, I see that exact problem.
Okay.
Can we go over that one really fast?
Was it that exact one?
Yeah.
Yeah, okay. And it was in cosine? Okay. Yeah, these are more typical. Think of this as a quadratic in disguise. It's actually called a quadratic in sine x. If it was cosine everywhere, it would be a quadratic in cosine x. You can have various quadratics. You can have a quadratic in e to the x. That is the same quadratic, only that's a quadratic in e to the x. So all you need for a quadratic is for this term to be the square of this term. Notice that sine squared is the square of sine. E to the 2x is the square of e to the x. That's e to the x times e to the x. Okay? So quadratics can be in every, they're not limited to just polynomials or x. So how would I factor this? Since it's a quadratic, we know we're going to have to factor it. Figure out both signs at the same step. What are both signs?
Oh, plus and then minus.
Uh-huh. That's always a great step when you're factoring. Figure out what goes there, figure out both signs. Now you're ready to do the last part.
And then it will be plus, oh wait, it'll be plus 1 minus 2.
Let's check onto my double smiley faces. Multiply the insides together, multiply the outsides together, add those two things, and that needs to be your middle term, and it is. So we did it correctly. Okay? Now what? Is the second one possible? What's the range on the sine function?
All the way to 2 pi.
No. The range on a typical sine function.
So it's just
Negative 1 to positive 1.
Yeah.
So you can't have the sine being equal to 2. This is an impossibility.
Yeah.
There's no such angle where the sine of that angle would be equal to 2. So we only have this solution. What's your domain on this? Is it 0 to 2 pi? Okay. So we need everywhere in the unit circle where the sine is equal to negative 1. Where is that?
2 pi. Pi. And
It's right here. Not pi. Pi is equal to 0.
3 pi over 2.
And that's the only place in that domain where it's equal. The sine is equal to negative 1. So that's your only answer. Okay? Now, these kind of problems can get more difficult if you have a mixture of trig functions. In other words, if this wasn't sine but cosine, like that, well, now I have to use trig identities. In other words, if you're given a trig equation that has different trig functions in it, those are the hard ones, because you want to turn them all into the same trig function in order to solve it. Hopefully you'll end up with a quadratic. Well, if I was given this, I would substitute for cosine 1 minus sine squared. Simplify and factor. Yeah, okay. I'll let you give them to me. What else you got?
Well, that was all I called from the initial on.
Okay.
Yeah, I think that was basically it.
When is your test?
It's next week on Friday, I believe.
Are you going to get a review material that's specific to the test, or have you already gotten it?
We're going to get it tomorrow, I think.
Okay. All right. Well, I'm good to go if you are, but I want to make sure you cover the material you want to cover, and you probably are going to have a lot of material to cover, and we're probably only going to have one more session, so Okay. You want to schedule it on your own, or you want me to bring up my calendar and let you pick a...
I'll go online and schedule it.
Okay, that works fine. You know how to do that well, I can tell. Okay, sounds good, Sarah. I'll talk to you next week. Bye-bye.